Hi, 5th grade. This is Mrs. Gyoko with your flipped math lesson for today, 3-6. Today's objective is I can multiply 2 and 3-digit numbers by a 1-digit number. So today we're going to use something called an algorithm. Rhythm. There we go. I spelled it. Algorithm. An algorithm is the way that your parents have been taught and your grandparents have been taught. So it's kind of like a shortcut for how to do something. So here's our first problem. There are 36 beads in each container. How many beads are there in 7 containers? So I'm looking at the problem. I'm going to find the important information. There are 36 beads in each container. So if I want to draw a container, there's 36 in each, and I have to find out how many are there in 7 containers. So if I drew 7 of these, then I would have to find out how many beads are there all together. So I know that that's going to be 36 times 7, and that's what we're going to find the answer to. So there's several ways that we could do that. Up here is the algorithm. So you have probably seen that before, I'm sure, and that's what we're going to be using to solve our problems today. However, we can still use our distributive property to find the answer. And in fact, when you use the algorithm, you are using the distributive property. You probably just didn't know it. I could take 36, so down here, I've taken 7 times 36, and I can take 36 and split it into 30 plus 6, and then I multiply the 7 times 30 and the 7 times 6, just like we did yesterday, I believe, with the distributive property. So 7 times 30 and 7 times 6, and 7 times 30 is going to be 7 times 3, which is 21, and then annex that 0, plus 7 times 6, which is 42. Now, up here, I've done the same thing with my model. I've taken the number 36, and I've split it into 30 plus 6, and I'm going to multiply this times this. So I multiply whatever's on top times whatever's on the side. So 7 times 30, I knew is 210. Then I multiply this times whatever's on the side. 7 times 6 is 42. Then add them up, and I should get 252, I believe. Let me double check. 210 plus 42 is 252. Yep, 252. Now, I'm going to use the I'm going to use the algorithm here to help us find the answer. Okay, so 7 times 6, I start by multiplying the 7 times the number in the ones place. 7 times 6 is 42. I put down the 2 and carry the 4. Oh, I keep hitting the button. Sorry. Now I'm going to multiply 7 times the number in the tens place. 7 times 3 is 21, plus 4 more is 25. 252 is my answer. It's the same answer I got when I used the distributive property. Okay, let's try another one. 63 times 8. So down here, I'm going to use the distributive property first. So 63 times 8, I can break 63 into 60 plus 3. So I'm going to multiply each of these times 8. So 60 times 8 plus 3 times 8. That's the same thing that's happening in our model. I've got the number 63, and I'm going to break it down into 60 plus 3, and then I multiply the 60 times the 8. So 6 times 8 is 48. Tack on the 0, or it's called annexing. So I'm going to annex the 0 and add that on there. Then I multiply 8 times the 3, you get 24. Then I'm ready to add it up. 480 plus 24. 8 plus 2 is 10, carry the 1, and I get 504. Now I'm going to use the algorithm up here to see if I get the same answer. Okay, so I'm going to take that away. 8 times 3 is 24. Carry the 2, excuse me, and then 8 times 4, 8 times 6. 6 times 8 is 48, plus 2 more, 48, 49, 50. 504 is our answer. Okay, how do you multiply a 3-digit number? Well, it's very much the same as multiplying a 2-digit number. So you can see you've got the algorithm. Down here I'm going to use the distributive property first to show you how I do that with a 3-digit number. So I've taken 347, and you can see that I have used the expanded form, which is what we've been doing, to show you that number, 300 plus 40 plus 7. Now I'm going to multiply each of these add-ins times 5. So I'm going to have 3 parentheses this time times 5. So I'm going to have 300 times 5 plus 40 times 5 plus 7 times 5. Okay, so 300 times 5, I underline the digits that are not zeros. 3 times 5 is 15. Annex those 2 zeros. Add that to 40 times 5. 4 times 5 is 20. Annex that 0 plus 7 times 5 is 35. Then add that all up. So 1,735 should be my answer. Up here at the top where I have our model, I can do the same thing. Okay, so 345, I've split that into 300 plus 40. Oops, sorry, 347, not 5, plus 7. Then I multiply each part times 5. 300 times 5 was 1,500. 40 times 5 is 200. And 7 times 5 is 35. Then add up each part. So that's just a model to show, it shows the exact same thing that we just did in the distributive property. So now I'm ready to use the algorithm to show my answer. Okay, so 5 times 7 is 35. I put down the 5 and carry the 3. Then I do 5 times 4, and 5 times 4 is 20, plus the 3 is 23. Then I do 5 times 3, oops, I forgot to, I keep doing that. Carry the 2. Oops, I'm making upside down 2. Having all sorts of problems today. Carry the 2. So 5 times 3 is 15, plus 2 more is 17. So I get 1,735, which is the same answer that we got when we used the distributive property. Okay, today you're going to find the product and estimate to make sure the answer is reasonable. Okay, so now I've shown you how to do the algorithm. We're going to use the algorithm, but we're also going to estimate to double check our answers. Okay, so first, before I actually multiply with the algorithm, I'm going to go ahead and round and then find my estimate, and then I'm going to go back to the algorithm and see if my answer is close to the estimate and if it's reasonable. So first I have 63. I'm going to round that down to 60, and then 8. I'm just going to go ahead and leave that 8. Oops, and multiply that together. Now, I don't have to use the algorithm because I know that 6 times 8 is 48, and then I just tack on that 0. So see how I just used that, did that mental math in my head? I know it should be about 480. Now, it's very, very important that when we estimate these numbers by rounding them first. Then that will give us an estimated answer. We don't find the actual answer and then round the answer. That would not make any sense. That's not how we estimate. Okay, so now I'm ready to do my actual multiplication with the algorithm. 8 times 3 is 24. Put down the 4 and carry the 2. Then I multiply 8 times 6. 6 times 8 is 48. Plus 2 more is 50. So I get 504. Now I'm going to check it with my estimate. My estimate was 480. My answer is 504. That's really pretty close. So I'm going to say that that is a good estimate. 274 times 3. So I'm going to round first. So 274, I think I will round that up to 300 times 3. I can multiply these in my head because they end in 0, so 3 times 3 is 9. Then I annex those 2 zeros. It's going to be about 900. Okay. Now I rounded up when I rounded 300, so I know it's going to be 900 is going to be an overestimate. Now I'm ready to do the actual algorithm. 3 times 4 is 12. Put down the 2 and carry the 1. 3 times 7 is 21, plus 1 more is 22. Put down the 2 and carry the 2. 3 times 2 is 6, and 6 plus 2 more is 8. So 822, that's pretty close to 900. So that was a good estimate, and I think I got the right answer. Okay, your turn. You're going to do the same thing. You are going to solve it by estimating first, then solve the problem with the algorithm and see if your estimate is close. Okay, go ahead. Okay, when I rounded 111, I got 100. 7, I just kept the same, and then 100 times 7 is 700. Then when I multiplied, I found 111 times 7 is 777, which is really close to my estimate of 700. So I'm going to give myself a smiley. Number 2, 873 times 6. Okay, when I rounded 873 to 900. 6 remained the same. Multiplied those together and got 5,400. Then I did the algorithm and got 5,238, which is very close to 5,400. So I did a great job. My answer is reasonable. Number 3, 795 times 5. Okay, I rounded 95 up to 800 and kept the 5 the same, and 800 times 5 is 4,000. Then I did the actual algorithm and got 3,975, which is very close to 4,000, so I did a reasonable estimate. Number 4, 227 times 3. Okay, so I rounded 227 to 200. 3 stayed the same. 200 times 3 is 600. And then 227 times 3, I found that to be 681, which is close to 600, so my answer is reasonable. Number 5, 459 times 4. Okay, I rounded 459 to 500. I kept the 4 the same. And then 500 times 4 equals 2,000. Then I used the algorithm to multiply 459 times 4 and got 1,836, which is close to 2,000. So my algorithm, or my multiplication, is reasonable. Okay, guys, we are finished for today. Thanks. Bye. See you later.